Hello everybody. Now let's check one new function of the DFL Seagate firmware repair tool. We just connected one patient Seagate hard drive to its DFL SRP firmware repair hardware. Okay, now let's check what happened to this patient drive if we power on the patient drive. We have connected this COM cable properly, and then we open this COM port and we go to this COM terminal and check, and we find out these kind of error messages. So the COM terminal output cannot get the SATA reset. That means, and we cannot enter the F3T prompt 2. And let's check further what kind of error messages or failure symptoms we can find out from this patient hard drive. Now we enter this patient hard drive with the program, and we can see that the capacity 3.86 GB. So this kind of wrong capacity can indicate the physical platter scratch failure or this kind of boot firmware failure. So the boot firmware, we can also call it as module 3D or SYS20D. And the model number is wrong, serial number also not correct. So we can enter the program. This is one 3F family patient hard drive. We enter the program. So for this kind of patient hard drive, how to fix? If we try to read something, we can also find this LED error here. No SATA reset, no F3T prompt, and 3.86 GB. So all this information are not correct. So what to do for this kind of patient drive? Let's first to back up the ROM, and second, let's go to the RAM operations and boot operations. Then click OK. Here, for this kind of patient drive, the very first thing is to try to do something on the ROM to change the boot process. Now we open the original ROM. Okay, this is original ROM. After that, we click Write Boot ROM. Here, the program will try to generate the boot ROM automatically. So users just need to click Write Boot ROM without short, and we select a high baud rate to write the boot ROM, and the program will start to write the boot ROM automatically. Now we just need to wait until the ROM write completes. So right now we are writing the boot ROM. Please remember this one. This is just to select the original ROM here, and then the program will generate the boot ROM, and users click Write Boot ROM, and then the boot ROM will be automatically written to the PCB. Now we can see that this is a baud rate we have just selected, and we are writing the boot ROM. This is the new function. We just need to wait and see the whole process, how to fix this kind of hard drive. So for some LED issue of other Seagate F3 hard drives with the SYS20D, or 3D module, we can use this method to write boot ROM and note the boot firmware. This is the boot firmware, and this is the boot firmware we have built in the program. Users just select this one, and users can select the boot firmware automatically. It's very easy to use. And for this family of the 3F family, for the 3F family, and we don't have the built-in ROD issue. So we can just select the 3D, the external 3D program. So we are now writing the ROM issue, and we can see if the booting ROM has been completed or not. So now we can see that the ROM write has been completed. Now the ROM write has been completed. So after we write the boot ROM, we need to power off and power on the drive. Okay, so after we power off and power on, we can see that it's DFL boot. So this is the sign of the successful boot ROM writing. So the next step, we need to load the external 3D module. Please note, 3D is the module name, and 2OD. Okay, we go to this one, LD 20D. So this is the 20D. So this is SYS file name. And here, this one is corrupted. We have backup, so we need to select another one. If we select this one, we will get the same issue of this, because this one is corrupted. All the issue is caused by this corrupted SYS file, so we need to select another $1 3D file or 20D file. I have got $1 20D here. Okay, so we need to select this one, the $20D. Same version, same firmware version from the same family. So 20D, this one, and then we select a higher baud rate to node boot firmware. Now the program starts to notice found the $20D SYS file. 3D, the same content of the 20D. Now after we node this SYS 20D, we go to COM terminal and see. Now we can enter the F3T prompt now. Now we can see before, we can see that the commands can be executed in COM terminal. This means we have already access to the SA error. Right now, we just write the 20D SYS file to the RAM. Please remember, this operation just nodes SYS 20D to the RAM, not to the platter. So after we can access to the SA, here we need to write the 20D here, 20D. Okay, 0, volume is 0 for 20D. Please note this one. And then we need to node from the donor 20D here. This is $20D. Okay, So we write SYS20D. They are writing to the platter, not to the RAM. So here, this is a difference. So this one is very important to load. Now I have import the $20D here, then I click write. Okay, no, please follow my steps. Click no, not check the SYS file. If you check, the checksum value can be changed, and after writing, it may cause problem. So here, when they write the $20D here, we don't need to check. Now I write as 20D, and then I can go to the COM terminal and check again. Now we just need to wait until the 20D is written to the platter, because we have learned that the original 20D was corrupted. So we need to find one good $20D to replace it. The problem is that when this 20D is corrupted, users cannot boot the drive properly, cannot get the SATA reset, cannot enter F3D prompt, cannot execute any command. So at this time, we can only write boot ROM and then load this boot firmware. The boot firmware is the 3D module or 20D SYS file. After we load successfully, here is to the RAM. Then we access to the SA. Then we write the 20D, the $good 20D to the platter. So after we written successfully, we can go to the COM terminal and execute some repair commands. After that, we write back the original ROM. Then all the issue has been fixed. So I just mentioned about the general process again, and let's just wait until this 20D written successfully to the platter. So this step is very important. Otherwise, if you don't write the SYS20D to the platter, if you power off the drive will go back to its original damaged status. So don't remember. Now we can see the 20D is being written to the platter. 64%, just need to wait. Sometimes when users receive cases, maybe some kind of other users format as A, and users may get the overlay failure issue. If users have the overlay issue, users cannot access to the SA normally. That means cannot read and write the SYS files or cannot read and write modules. If users get the overlay issue, so users need to do one extra step. That is to write the LOD. LOD means the overlay. So users can write LOD within the COM mode. Even if the drive keeps busy, users can use this one. Write is LD and then write is 20D. If the drive's SA can be accessed directly, then users don't need to write the LD by command here. For this drive, after being load the 20D successfully to the RAM, and the users can access to the SA, can go to the F3T prompt. So users can directly write the SYS20D. Sometimes not, if not. So try to think about writing the LD by command. Okay, write success. So after this one, we can try go to F3T. We check before M063. At this time, we can try, we write back already is 20D and done the repair, and we can try to power off and power on, and let's check what happened here. Okay, let's go to re-enter the program. See, so the drive ID has been back. We can see the capacity is correct, the model correct. So modules are available here too. So the drive, the 3.86 GB has been fixed. So the last step, we need to write back the original ROM write back the original ROM. Select the original ROM without short. Why do we need to write back the original ROM? With the boot ROM, users can also access to the data area. But sometimes, if the drive has a lot of bad sectors and need soft reset, hard reset, and power reset, for this kind of reset, it may cause the hard drive not detectable. So the image can get interrupted. In order to avoid this kind of situation, so users must write back the original ROM, and the drive will keep being detected and ID'd properly. So this is why we need to write back the original ROM. Now this is the last step. When users get similar cases, so users can try to follow this video to fix the case with this new function. Now original ROM has been written successfully to expansion drive. Now we can power on drive. See? Control L. So everything is perfect now. When we try to scan the hard drive, we need to go to the AT mode. See? So the drive has been fixed, like this one. We can go to the DFL DTP data recovery program and extract the lost data. Thank you for watching this video.